Wouldn't it be nice? See the world was gone. Na 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 na. At least I got the rhythm right.
I love that song.
I know that's one of my favorite songs at all time. All right, all right. Go ahead, Jack. Go ahead, Matthew. You should be good to go. All right. Anyone else? Okay. Yeah. Go ahead, Jack. Try again. Okay. So, chapter 10 start with hypothesis testing. So, what is this about? All right. So, this is to see whether our result is good to moving on, right? Otherwise, it's gonna be tough. Uh, you don't have something to compare, then it's hard, right? Okay, go ahead, Alisa. You can go record it again. So how do we know whether our result is accurate? Then we have to compare with the previous result. And if we are somewhere way far away from the previous result, meaning that we need to conduct more survey or do analysis again. If we are within the region of the previous result, then we should be able to moving on. Or sometimes our result is much better than previous result, then our result will be recorded as the permanent replacement. And then we're waiting for some other research to see whether other research will be better than our result. And this is exactly what chapter 10 is, right? Hypothesis testing. So in order to prove that our result is better, we need to have evidence, and we have to present our evidence. And then the judge, right, can make a final decision to see if the evidence is legit or not. If it's not legit, then we have to do more survey. If it's legitimate, then we are successful defending our result, right? So that kind of the system is we're gonna go through here, right? So before we can prove our case, the previous result will always be true no matter what, right? So that's the idea of hypothesis testing. All right. Now we will have two cases. The first one is the null hypothesis. So the null hypothesis, denoted by H naught, this will be the initial statement that we have, right? So this is, you can imagine that this is the previous result, meaning that it will always be true until proven wrong, right? So this state of population parameters could be the mean, proportion, or the standard deviation will equal to some values, all right? So it will always have an equal sign because that's the previous result. We have to respect it, right? So the null hypothesis is the initial claims and needs to be tested, right? It is assumed true until evidence indicates otherwise. Therefore, we always test to reject or do not reject the null hypothesis. Okay, so it's not about right or wrong here, right? It's just about a better result or not a better result. So we just say reject or do not reject. So when we reject, mean that we will take the new result and replace the old one. If we do not reject, then the new result is not valid. Therefore, we have to keep the old ones. Okay, so that's going to be the two scenario we're going to deal with here, right? Reject or not reject, right? So that's the null hypothesis. Now, the alternate hypothesis, denoted at H1, stated that the population parameter could be the mean, proportion, or the standard deviation has a value that's different than the one in the null hypothesis. So for that, we could have three cases, meaning that the first case is does not equal to the null hypothesis, or could be less than the null hypothesis, or could be more than the null hypothesis. So this is alternate hypothesis, right? This is our result. So we can say, yeah, here's the example. I can say that, okay, right now I have $20 in my pocket. So that's my statement. That's my null hypothesis. And then you said, I don't think so, Mr. Vo. I think you have something not equal to $20. So that's the first case, doesn't equal to, right? So your claims that I don't have $20 could mean that I have more, I have less. So if you can prove that I have less than $20 or I have more than $20, then you win the case. So that's the first case of doesn't equal. Or you can say that, Mr. Vo, I think you have less than $20. Then you need to show that I have less than $20 for you to win the case. If I have exactly $20, I have more $20, then you're not winning the case because you claim that I have less than $20, right? So that would be the second case. And in the third case, you're gonna claim that, Mr. Vo, I think you have more than $20. Then you have to prove that I have more than $20. That's the only way you can win the case. Okay, so that's how we're looking at three different perspectives for the null for the alternate hypothesis, right? So H naught will always equal to a certain numbers, and H1 will be divided into one of the three cases that we just presented here. Okay, so therefore, when the null hypothesis is rejected, we will take the alternate hypothesis as a new claim. Okay, so that I told you before, right? If our result is better than the previous one, then we will take our result as a new comparison for anyone else who would like to do a further research. Right? That's the idea. Okay. All right. So if we cannot reject, then we still have to keep the original result as for the next hypothesis testing. Is that introduction of what is chapter 10 okay so far, right? So that's kind of the description of what's gonna be. All right, so now we will have three cases to set up, right? As I mentioned before, we have two tail tests designed for doesn't equal, because you can, as long as you can prove that that person doesn't have exactly, could be have less, could be have more, so that we call that two tail tests, right? All right, so that's case number one, right? So the key words for two-tail will be different, not the same, or has changed, right? So those are the key word for two-tail test. And as I mentioned, H naught, our parameter will always equal to some values, and H1, our parameters does not equal to some values. That's case number one. Case number two, right tail test. Right, right tail test. The keywords to look for will be increase, greater than, larger, more than, higher, more, and so on. And the key right tail test, H naught, the parameter still equal to some values, and H1, the parameter will bigger than some values, right? So that's for right tail test. Case three, right? Case three will be left tail test. So left tail test, the keyword for is decrease, less than, reduce, smaller than, lower, less, and so on, right? So those are the 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 key for right to the left tail, and the parameter will be equal to some value again for the H naught, and H1 will be parameter will be less than some values. Okay, so those are the instruction for those three cases. In general, it is harder to determine the two-tail test. It would be easier to determine whether it's a right tail or left tail. Therefore, we should try to do a method of elimination, right? It's have to be one of the three cases. So it's kind of a trick, right? Look for right, left, right? first, right? If none of the two cases occur, then it is two-tailed. Okay, because we only have three cases. If it's not left, if are not right, then it have to be two-tailed, right? There's no oh, I'm gonna have a four case. No, all right. So that's kind of a trick to look for a two-tailed test, right? All right. So here we go. If you look at this description, let's see if we can tell whether it's two-tailed, left tail, or right tail. All right, what do you guys think? Two-tail, left tail, or right tail? It's two-tail, right? Thank you very much, Matthew. And the keywords here is it's different than 2%. Okay, right. So the null hypothesis will be it is 2%, and then a researcher said I don't think it's 2%. It's different than 2%. There you go, two-tail. Okay, so because of that, we know that it's two-tail. So the null hypothesis, right, H naught. So they want to look at the percentage right here. So we have to look at for proportion. So we have P is equal to 2%, right? Or 0.02. And then the alternate hypothesis, P does not equal to 2%. In other words, P does not equal to 0.02. Okay, that's all it does. So that's the null hypothesis and the alternate hypothesis. Okay. All right, second example, number 2. What do you guys think is gonna be?
Do you mind scrolling up back to example 1 for me, please?
Watch water.
Train me down. A little bit higher, please.
Yeah.
All right, thank you.
All right, number 2, right tail test. Very good, very good. All right, so it will increase, right? So you can see here, indication that will be right tail. All right, so talk about the average, right? So that's talk about the mean. So in an alternate null hypothesis, mu is equal to 8.6, right? Because 8.6 pound. In an alternate hypothesis, mu is bigger than 8.6, right? Just like that. All right, so null hypothesis and an alternate hypothesis will use the same numbers, and the claim is null hypothesis is the same everywhere, and the alternate hypothesis it could be different, more than, and so on. All right, how about number 1? Not number 3. There you go, left tail for sure. Right, it said less right here, so gonna be left tail, right? All right, so this one talk about the standard deviation, right? So the instruction is very clear, guys. Okay, so in the null hypothesis, sigma equal to 0.23, and in alternate hypothesis, sigma is less than 0.23. Just like that, right? And that's the introduction. Okay, everything good so far? Yeah, just get started, right? And that is very important, right? Looking for the keyword, because the whole thing gonna depend on that tail that we decide, right? Because the test for two tail is different from the test for left tail and also the right tail. So we have to be very careful with that decision, okay? All right, so now we try to stick to two type of error that we're gonna see normally here, right? So the first type of error is that rejecting the null hypothesis when it is in fact it's true, right? So reject the null hypothesis when it's true, right? So this is the type 1 right here, right? All right, so we are rejecting the null hypothesis, even that though it's true. So how do we relate that? Well, you know for sure that I have $20 in my pocket, but you rejecting that decision, right? You know for sure that I have $20 in the pocket, but you don't want to say it out, and you said that, oh, he doesn't have $20 in pocket, right? So that's what we call type 1 error, yeah? Now, type 2 error is we do not reject the null hypothesis when in fact it is false, right? So this one here, we look at type 2. All right, we know it is false, but we don't rejecting it, right? So we are making a type 2 error, right? So same thing, you know for sure that Mr. Vo do not have $20 in the pocket, but you still saying that yes, he do have $20 pocket, right? Right, so that's the difference between type 1 error and then type 2 error, okay? So that's just to watch out for those little detail, right? All right, so now the probability of making type 1 error, that is of rejecting a true hypothesis, is called the level of significance alpha of a hypothesis testing. So we want to find out how many percentage we're gonna make that error on that. Okay, so we call that level of significance, so alpha. So we've been knowing alpha already, right? So alpha is if you go back to chapter 5, chapter 9, then alpha will be how many percent that we are not confident, right? So we bring that back again. All right, so here we're going to have 3 scenarios. We're gonna have for proportion, the mean, and the standard deviations, okay? So here will be the breakdown for 3 cases. And this is the setup we're gonna follow. All right, so as you can see here, section 10.2 is where we look at P equal to P naught, right? So P naught will be something that is given in the problem itself. If you look at the first example, right, P naught is 2%, right? So that's something have to be provided. We cannot make it up, right? So on your exam, you're gonna look for that information, right? We cannot say, oh, I'm gonna find it and then use that. No, it will be already provided. All right, so if you look at proportion 10.2, all right, case number 1, two tail, you have P that equal P naught, and alternate P doesn't equal to P naught. Left tail, you have P equal to P naught, and then P less than P naught using the same number. And then right tail, you got P equal to P naught, and P is bigger than P naught, right? So that's 10.2. And then 10.3 is where we're gonna focus on the mean, same scenario, but we replace P by the mu, right? So mu equal mu naught, mu doesn't equal to mu naught, and so on. So that's 10.3. And then 10.4 is where we focus on the standard deviation, right? So sigma equal to sigma naught, sigma does not equal to sigma naught, and so on, right? So depend on the situation, we're gonna deal with that. So you can see the last column, is kind of a picture of each tail, right? So you can see that when you talk about two tail, as long as the critical region of alpha, it could be on the left hand side, could be on the right hand side, as long as it's fall within those one of those two, then we should be good to go, right? You can see the left hand side, you only have one Pacific area on the left. Similar for the right hand side, we only have one Pacific area from the right hand side, right? So those are kind of a summary of an overview of what chapter 10 is going to be. And then we're going to go into detail of each section, right? 10.2, 10.3, and 10.4, right? So 10.1 is show it how it's going to get done. And then we're going to investigate one by one. All right, so for each of the sections, we will have evidence, right? So what is our evidence? So our evidence will be considered at T naught, Z naught, and chi-square naught, right? So those are our evidence. So for proportion, Z naught will be found by the formula P hat minus P naught, and then divide by P naught 1 minus P naught over N. So you can see here, P naught will be given. We don't have to find it. And P hat we renew, right? So P hat equal to X over N. So that's something you can find, but P naught will be provided already within the question itself. For the mean, mu naught will be provided, right? So again, mu naught will be given. So this one here, you can find it, right? So you want to find the mean of the sample, you can find it. All right, so same thing with the standard deviation, sigma sigma naught will be given, right? And then S, you can find it, right? Whatever that one is, okay? All right, so that we have two formula. We have critical, there's two methods. We call the classical method or the modern method. We will use the modern method, okay? Because first, it's convenient for us as the Zoom class. Number two, it's easier for the student. Number three, we have technology. We can just use it. We're not gonna go with the critical method, okay? So what you're gonna learn will be modern methods. So if you are doing homework and you see some classical method, just send me an email so I can take care of that. Okay, it's a generating homework, so just let me know. Right, but we always gonna go with the modern method, right? So we're gonna go with the p values, right? So we call that the modern methods. So I also give you here the instructions of how to find the area for each tail, right? All right, so for proportion, we're gonna use normal CDF. For the mean, we're gonna use TCDF, and then for the standard deviation, we're gonna use chi-square CDF, okay? So different section using a different test, right? Proportion is different, the mean is different, and the standard deviation is different. So just be careful what you're gonna choose, right? Because when you use a wrong test, everything will collapse. All right. All right. So if you want to use a normal CDF, you always start with the left value, meaning that the smaller side, and then the right value, and then 0 and 1. For the TCDF, we still the same thing. We have left values, we have right value, and then n minus 1. Yes, Matthew.
You said if we use the wrong test, the thing will collapse. Is there a way for us to check or verify that we use the right one, or would we just get a wrong answer and there's no super tones?
That's why when you read the problem, it's very important that you have to decide. And I mentioned that we look for the keywords, right? You have to look for if you look for proportion, then you're gonna look for percentage and so on. If you look for the mean, you're gonna look for the average and then the standard deviation. They are very clear instructions, Matthew.
Got it. So if you misread the question, there's no way to check your answer.
Exactly. Yes.
Okay.
Yeah. So you're gonna read it very carefully. Okay. All right. So here is just a summary of chapter 10. Right. So we're gonna go into each of those details in a little bit, but this is what we're gonna go through. All right. And The book, layout have a different layout, but for me, I'm gonna show you what I want to construct, right? For example, this is what you should do, and this is what you should do, and so on. And you're just gonna follow this, right? So even on the exam, I will have the exact layout like what you see here. So you just have all you have to do is fill out your part, right? Information here and there. Okay. All right. So why? Because for the homework, they don't ask you step 1, step 2, step 3. They just give you a problem and you have to decide everything else. Even when you read the book, they have the same layout. However, for me, I think this will be easier for student, right? Because you just have to, instead of you figure it out, oh, this is what I have to do for part 1, this is what I have to do for part 2, and so on. I'm giving that instruction already. So you just fill out your part and then you follow the step and then make the decision in the end. Okay. So 10.2, we try to look for the hypothesis testing for population proportion, right? So again, what we have to look out for will be percentage, right? Or something related with ratio, right? Right. So those are the keyword for proportion, right? Or you have about proportion, you look at the probability of success in n trial. Okay, so that's what proportion is about, right? How many times we get a sudden successful, how many times that we try it out. Okay, so there will be no way we can miss that in the mean standard deviation, right? Instruction is very clear. All right, number 1, check conditions. So in this way here, we have to check if the n times p and then 1 minus p is bigger than 10. If that's good to go, then that's all we need, right? So that's number 1. So make sure you do that on the exam, right? So number 1, I will have that layout. So don't worry that you have to memorize it. You don't have to memorize this. I will have the exact layout for you on the exam. Your part, I just fill out the blank, right? That's number 1. Number 2, we have to decide, and this is very important, right? You have to decide whether two tail, right tail, or left tail. All you have to do is circle 1, okay? Circle 1, and then you go from there. And then number 3, you write out the null hypothesis, and then also the alternate hypothesis, and make sure you know what's the claim gonna be, right? What we try to prove, and so on. And number 4 is where we presenting our evidence, where you can calculate Z naught. So again, the formula will be P hat minus P naught divided by square root of P naught 1 minus P naught over N. Okay, so that's step number 4. And then number 5, just have to draw a diagram so that we can know which one we're gonna go with, right? Draw a diagram and then find the P values. Okay, so here we have 3 different cases, right? So I also give you the instruction how to set it up, right, for each of the case. All right, so for two tail, then we have the p value will be 2 times the probability of z bigger than absolute value of z naught. So the command will be 2 times normal CDF absolute value of z naught 10 to the 99, 0, and 1. Right, so make sure you write that instruction down on your notes. Okay, and then for left tail, we have normal CDF negative 10 to the 99, comma z naught, comma 0 and 1. And then for right tail will be normal CDF and then z naught 10 to the 99 and then 0 and 1. Okay, so very clear. So everything are provided. So your part is make the right choice and follow along. That's all you have to do, right? I make it hypothesis testing very straightforward and easy for you guys, right? The book doesn't have this layout. I don't know whether our other instructions are the same, but for me, that's what I want you guys to figure it out, right? So that you don't have to go through the issue of, oh, how do I start number 1, number 2, number 3, right? Everything will be provided. Okay, is that good so far? All right, so, and this is number 6, very important, right? The only thing we check is we compare the p-value with alpha. So if p-values is less than alpha, then we will reject the null hypothesis. So in other words, if this is true, right? If this is true, then we are the winner. That's it. So we try to prove whether someone else is good or not. If p-value is less than alpha, then we are the winner. So we have to reject the null hypothesis, meaning that the alternate hypothesis will become the new evidence. Yeah, so that will become the new evidence. So that's all we look for. If p-value is less than alpha, then we reject the null hypothesis. If not, then we don't reject the null hypothesis. So therefore, step number 2 is very important, right? Because if you choose the wrong test, right? For example, if you choose 2-tail, then over here you have to double up, right? There could be the case that when you double up, you make it bigger than alpha, but reality it have to be one of the other tail, then it's supposedly to be less than alpha. So number 2, from my point of view, is very important. So make sure you read the problems and decide which tail is that going to be, right? And I show you the trick already, right? Look for the right tail, look for the left tail. If you don't see any of those, then it's going to be 2-tail, and that's how we're going to follow, right? Very, very important. And number 7, again, number 7, number 6, they are not the same. Number 6, you make a decision whether you reject or do not reject the null hypothesis. And number 7, we have to state our claim, right? If we reject, what will happen? If we do not reject, what will be happens, right? So number 7 is the conclusion. I'm going to show you all that from step 1 to step 7. Okay, so make sure you wrote this instruction down, right? Especially step number 5, how to find the area under curve for 2-tail, left tail, right tail with the calculator instruction too. All right, pause here for a second, just in case you want to ask any questions or any concern. Let me know before we go ahead and start the first example. All right, so let's go. All right. All right, according to a survey conducted by the Associated for Dressing and Sauces, 85% of Americans adults eat salad at least once a week. Okay, so you can see here, 85% is have to be proportion, right? Does that make sense here, Matthew, for your question before, right? How do I know, right?
Mm-hmm.
Very clear instruction, right? 85%. There you go. There you go. 85%. It's gonna be proportion, right? You see percentage, so it have to be proportion. All right. So that would be the first P, right? According to conducted by Associated for Dressing and Sausage, 85% of American adult is at least once a week. So there we go. That's provided. So that would be my P naught, right? P naught equal to 85%. Okay. So P naught will always be given. You don't have to do any calculation to find P naught. Will be provided, right? a nutritionist claimed that the percentage is higher than this. She conducts a survey of 200 American adults and find that 171 of them eat salad at least once a week, right? You can see that, right? 171 eat salad. That's the successful. Make sense? So all we're gonna be in that case, right? So 200 Americans, therefore my n will be 200. 171 of them eat salad at least once a week. That will be my x equal to 171. All right, check conditions. NP 1 minus P bigger than or equal to 10. So we get 210.85 and then 1 minus 0.85. We get 25.5, so bigger than 10, so we good. All right, so
Just
condition
as a review, if it was less than 10, do we just stop there and say we can't proceed?
That's right.
Okay.
Meaning that the sample size is not big enough to do a survey, to do a hypothesis testing. All right, number 2, very important. Which tail is that?
I have a question about number 1.
What is that, Matthew?
Is that 200 times 0.85?
Yeah, 201.85, yes. And then 1 minus 0.85. All right, number 2, which tail?
Right.
Right tail, very good, right? All right, so see, the condition expect to be higher than this, right? So we're gonna be right tail. Okay, so the instruction is very clear, right? You just have to pick the right one, right? All right, circle right tail, so you write out, this is talk about proportion, so I have P is equal to 0.85, and then right tail will be P is bigger than 0.85, done. Okay, and now the evidence, the test statistics. So we have the formula provided at P hat minus P naught, and then divide by P naught, 1 minus P naught over N underneath the radical, right? All right, so we have P naught, well, but we don't have P hat, right? All right, so P naught is 85%, which is 0.85, and then P hat. So how do I find P hat?
Would that be 171 over 200?
That's right. P hat will always have the formula x over n, which is 171 over 200. All right. So 171 divided by 200. So we got 0.85 and 5. Okay. So the hypothesis testing is very important. So we always use enough decimal, right? Don't use 1 or 2 places because sometimes they happen to be the same and we don't have what we need, right? Okay, so the test statistics. So we have Z naught equal to P hat minus P naught and divide by P naught 1 minus P naught over N. So 0.855 minus 0.85 divided by square root of 0.85, 1 minus 0.85 over 200. I do one at a time. Get 0.005, and let's see what we got down here. So I get 0.0252, right? So we got 1.98. So you know, Z naught, so we're gonna use 0.20, okay? So Z naught, we have 2 decimal place, so we're gonna 0.20. Still good so far? Yeah, just plug in the calculator and then write out the numbers. All right, number 5, draw a diagram so we know exactly what we're dealing with, right? So we have the right tail, right? So we shade the area to the right. So we have 0.2 here, and we want the area to the right. So we know what command you're gonna use. So p values equal to the probability z bigger than 0.20, right? It's right tail, right? And this command equivalent to normal CDF, and then 0.20, and then 10 to the 99, and then 0 and 1, right? Normal CDF. Let's see what we get. So we get 0.4207. All right, so that's p-values. All right, it's comparisons. Is that, all right, so this is statement that is that if p-values is less than alpha, then reject the null hypothesis. So that statement is what we need to follow. Okay, so let's see. P-values equal to 4207, and then alpha equal to, what is alpha equal? Alpha will be provided, okay? All right, so what's alpha? Alpha is 0.05, right? So it's given in the problem itself. Alpha equal to 0.05. And you can see here, so sin 0.4207 is not less than 0.05, so we do not reject the null hypothesis. Make sense?
Do we always use less than X, less than alpha for?
Less than alpha. Mhm.
Always less than alpha to?
Always less than alpha, no matter what. And that's what I like about the modern methods. We only compare to alpha. For the critical, you know, the classical method, we don't compare alpha, but we compare to some fixed number. And then every time we have a different fixed numbers. Okay. Yeah. So that's why, yeah. You know, I learned from doing it. The first time I was taught the class, I used the classical method, and it was a disaster for my student. I didn't realize that, and then, man, why should I did that? And then after that, I just moving on to the modern methods, and here we are. Right, modern method would be a better choice for the student. Okay, so it doesn't matter which sections or which tail, we always compare to alpha. If p-value is less than alpha, then reject the null hypothesis. If not, we don't reject, that's all, right? All right, so p-value is 0.4 and alpha is 0.05. So clearly 0.4 is not less than 0.05. So we do not reject the null hypothesis.
How did we get alpha again?
It's given, Grayson. See that?
Where at?
Right here.
Ah, thank you.
Mhm.
Professor, number 4,
Yeah.
how did you get 0.20?
0, because when you do that division, you get 0.198, and z-score will always use 2 decimal place, Victor.
Oh, got it. Thank you.
All right, so everything okay so far before number 7. All right, so let's go back to the claim that is higher, right? Yeah, it's higher, but we failed to prove that, right? So here's the deal, right? For example, I said, right, 85%, and then someone in the class said, well, I think it's higher, but now you fail to provide your evidence. What does that mean? Which means that Mr. Vaught is right? So since we don't have enough evidence, meaning that we still need to use that result. So 85% still good to go. Does that make sense here, guys? So that's what we call hypothesis testing, okay? So we try to prove whether the previous one is correct. If we can reject it, then we have a new claim. If not, we're gonna stick to the old one, right? So that would be number 7, conclusions. All right, so we're gonna write it. Sin. Right, so this is the statement you're gonna see on the homework, and this is what we're gonna use that on the test too. So since we cannot, we do not, right? Since we do not reject the null hypothesis, there is insufficient, right? There's insufficient evidence to show the percentage of adult eat salad once a week is higher than 85%. Okay. All right, so since we do not reject the null hypothesis, there is insufficient evidence to show the percentage of Americans adults eat salad once a week is higher than 85%. We don't have evidence to show that, so we call that insufficient evidence. Does that statement make sense? All right, so that that is how the homework layout. So I want you guys to get used to that statement concept when you do your homework, right? Questions? So the good things about hypothesis testing is that doesn't mean that we are wrong, okay? It's just that we don't have enough evidence to override the old decision. Meaning that we need to find more evidence, or we should conduct more survey and see what's gonna be turned out, right? Or when you ask 200 people and 171 of them say that yes, they eat salad once a week, but then there could be we conduct a wrong survey or we do something that's so convenient, right? So we have to go back and refresh our research one more time so that we get the expected result. Okay, so so you can see here there's no right or wrong. We just don't have enough evidence, right? We just have insufficient evidence to show that it's true or not. Okay, so that's number 7, conclusion. And on the exam, this is my expectation, right? So I'm gonna write out all of that. You just have to fill it out and using the right place, right formulas, and then right results. Is that okay? I'm gonna make it very easy for you guys. All right. All right. Next example, example 2, please go ahead and try it out. Try it out from start to finish, right? So here's the instruction again. You didn't print it out, and this is exactly how we're going to look at that. 1, 2, 3, 4, 5, 6, 7. Okay, go ahead and give it a try on your side. So once you're done with that, put in a chat box which tail is your decision, and then what's your p-value, and what's your conclusion, reject or do not reject. Okay.
Professor, do we use the same conditions for this one? The check conditions?
That's right. It's
Okay.
proportion to the same condition. Yes.
Okay, got it.
Okay, you should be able to check that and see your result.
So Professor, I have a question for number 5.
Uh-huh.
I did normal CDF and the numbers that I got was 0.0348.
You have to times it
But
by
the-
2.
Say that again?
You forgot to times it by 2.
Oh,
Why are we timesing it by 2? Where does it say that in the notes?
It's two-tail method.
Okay, yeah, but where does it say it in the notes? I'm missing that.
The first page of 10.2. Let me see. Right here.
Yep, it says that right in plain sight. Now, thank you.
Mhm.
oh, I see. I missed that part.
Yeah, make sure it has to be absolute values.
So if
Yeah.
we make that mistake in exam, would you forgive us for that one?
Depend whether you make a rejection or don't reject, right? Yeah, sometimes it's very important, right?
Yeah.
Yeah, because two-tail, right? Two-tail, it is symmetric, so therefore it could happen in the left or on the right. So we double the area, so that's why we times it by 2. Yeah.
Okay.
So only the two tail is in absolute values, right?
That's right. Only the two-tail
Okay.
absolute values.
I have a question.
Yes, Jackson.
This is Austin.
Yes, go on, Austin.
So for number 4, I got 1.82 instead of 1.81. So on number 5, I got 0.068
Mhm.
instead of what you got, but it still was less than the 0.1, so I rejected it. On the exam, would you mark me wrong for that, or?
Yeah, that's why I need you guys to show the work, right? Because if you don't show the work and you got something different than mine, then I have to deduct point. But if you show the work, then you still get full credit. Austin.
Okay.
Yeah, so I'm gonna ask a student to like use 3 or 4 decimal places so that we all on the same track. Yeah.
Oh, okay, that makes sense.
How many did you use?
For number 4, I divided 0.04 by 0.022
2.
instead of the 221.
I see. You missed a 1 decimal. Yeah. Yeah, that's why it's important that you show the work, Austin.
Okay.
All right, Jackson, go on. You raise your hand.
Okay, so if our p-value is less than our a value, we reject h0.
That's right.
So and in this question, h0 is that it has changed.
No, H0 is 58%. Yes.
Okay.
And then H1 will be it's not 58%. It has changed, but it could be less than 58% or could be more than 58%. But we know it has changed. It's no longer.
Okay, so has changed is h1.
That's right. Yes.
Okay, cool. That was my question.
Yeah.
When we're doing our calculations, is it safe to use for Z to do a round to the 4th place?
No,
For
Z
the
always 2.
denominator?
Always 2.
No, I mean when we're doing the calculations, not for yeah. Okay.
That's right. Yeah, 4 decimal places for numerator and decimal and denominator if that apply. Yeah.
Okay.
To be safe. Yeah. Because when you do the comparison to alpha, right? So sometimes it's very easy to make it bigger or smaller. Yes. Yeah. Yeah, so I will put like put the answer into the 4 decimal places, except for Z, and that's how you gonna see on the same page. Okay, everything's good.
So Professor, please can you show me how you got so how did you get the 0.0703? I'm trying to do it on my calculator. It's still not giving me that numbers.
Yeah, for sure. Adams, because chi-square is not symmetrical, so they don't have the inverse chi-square for that, because on the left hand side and the right hand side they can be different two chi values. Okay. Yep, I think I answered that question the other way, but should be okay. All right, so Victor, second bars and normal CDF 1.81, and then OPA will be 10 to the 99, and calculate, and then you times it by 2. Done.
Gotcha.
Yeah.
Yeah.
Yeah, so you do normal CDF first, and then you times it by 2 after you got the probabilities. Okay.
Okay.
All right, not bad, isn't it? Yeah, I know some you see here it's about like how you make it easier for a student, right? Because if I don't have all that instruction down and you have to go ahead and do everything by yourself from 1 to 7, it's gonna be tough, right? So that's why my first semester I feel kind of bad for my student, because I make them do from start to finish. Because to me it was okay, but then I didn't learn that lesson. So I learned that lesson after my first semester. Yes, Austin, go on.
One quick question. For 5, the two numbers on the diagram, would that be negative 1.82 and 1.82 or 1.81 in this case?
Yeah, so those are two numbers. So negative 1.81 and then positive 1.81. And that's why we double it up. So we just take one of them, you times it by 2. And that's the reason why we do absolute values. Because sometimes you get a negative Z score. You just have to make sure that you got everything. So you make it a positive, right? Double it up.
Gotcha.
Okay, so second exam, you guys should be doing better than first exam. Very specific instructions, right? Proportion, means, standard deviation, it's all given in the problem itself. So it's just don't pick the wrong one, okay? All right, any other comments or concerns that you would like to ask or share? Yes, Matthew?
I have a question. It's not really about this. I was just thinking about the test for quiz 1. You said you're going to put that on a curve. When are we going to get the updated grade?
Probably today, because I need to finish my other class. I do 2 classes in the summer. So I just want to finish that's grade 2. So when I download the file, I can download for both and then do the curve at the same time. You know what I mean?
Okay, so today, maybe tomorrow, we should see the updated grade.
Yes.
And you're going to input that in Canvas, correct?
That's correct, yes.
Perfect.
Yeah, it will. It will be curved. Don't worry. Okay. I think it will be curved because the average is not that I expected. I already have that assumption because it's a probability chapter involved. That's always the nightmare.
Yeah. Only 51%, I think, was our average. Might have got up to 52.
So that's probably gonna 20% curve, huh?
Hopefully.
Hopefully. And don't forget your homework is also, you know, push you up with the overall average too. And again, the reason I don't upload the homework's grade because it's still going on, right? And it's still accumulating, so I don't want to do one at a time.
And do you offer extra credit for this class at some point in time?
The curving is what I have for extra credit. Because
Okay.
other semester I give the extra credit, but I don't curve any exams. So
Got
yeah,
it.
the curving will be very better because, you know, extra credit may be 10 points, but the curving, for example, you could have 20% for the first exam. So that's always better. Depends. Okay, so yep, that should be good for today. 2 sections. Tomorrow we'll do then the rest of the chapter 10, and looking forward for the review on Wednesday and the exam on Thursday. So I'm gonna finish up the exam review package, and then we'll upload to Canvas, and you can start doing it right after today's class. Okay, so give me 30 minutes or an hour. So roughly around 1 o'clock, you should be able to see the exam 2 review, and you can start working on it. Okay. Tomorrow will be the last 2. All right. Okay, so I'm gonna go ahead and take attendance real quick, and you do have question that you want to ask, stay back after the class. If not, give me an hour, and you can start download your exam review package, and you can work on it. All right. Okay. All right. All right. Iron, Africa.
Yeah, I'm ready.
All right. All right, Grayson. Good to see you back. Adams.
Here.
Thank you. Matthew is here. Jackson.
Here.
Thank you. You got the message, Jackson?
Yeah.
All right.
Yeah.
Katie.
Here.
Thank you, Katie. And Jake.